Good morning. Today we are going to start new chapter, Electrochemistry. Electrochemistry is a branch of chemistry which deals with the relationship between electrical energy and chemical changes taking place in a redox reaction. That is, how chemical energy produced in a redox reaction can be converted into electrical energy and how electrical energy can be used to start a chemical reaction which is non-spontaneous. So, in this chapter, we will be dealing with redox reactions. And you know what are redox reactions? Reactions in which oxidation and reduction takes place simultaneously. Now, you know, in redox reaction, we have oxidation. So, in terms of electrons, we say that oxidation is the process which involves loss of electrons. So, during oxidation, a metal will lose electrons, and reduction is a process which involves gain of electron, or we can say a metal gets reduced by gaining electrons. Now, what do you mean by oxidizing agent and reducing agent? An oxidizing agent is a substance that helps in oxidation, and the oxidizing agent will get reduced. And the reducing agent is a substance that helps in reduction, and the reducing agent will get oxidized. So, in this chapter, electrochemistry, we will be dealing with redox reactions. And in this chapter, you will learn about two important types of cells. The first one is electrochemical cell, and the second type of cell is electrolytic cell. So, first let us see what is an electrochemical cell. Now, electrochemical cell can also be named as, it can also be called voltaic cell or galvanic cell. So, electrochemical cell or voltaic cell or galvanic cell means the same. Now, we are going to discuss the construction of an electrochemical cell using Daniell cell as example. Daniell cell. So, the electrochemical cell is explained taking Daniell cell as an example. So, I have drawn here the diagram of an electrochemical cell. In the diagram, you can see there are two portions of a cell. These are the two portions of a cell, or we can say two beakers are drawn. And the portions of a cell, one portion of the cell is called oxidation half cell, and the other portion of the cell is called reduction half cell. Now you can see inside the half cells we have electrodes. This half cell, this is the electrode, and in this half cell this is the electrode. And the two electrodes are dipped in electrolyte. And in oxidation half cell I have marked the electrolyte, that is zinc sulfate, and the electrode in oxidation half cell is zinc. And in reduction half cell, the electrode is copper and the electrolyte is copper sulfate solution. So, in both the half cells, the electrodes are dipped in the solution of their own salt. Now, the two electrodes are connected by a wire and an ammeter or voltmeter. Now, the electrolyte or the solutions are connected by a U-shaped tube called salt bridge. Now you can see the anode is negatively charged and the cathode is positively charged. So in an electrochemical cell, anode is negatively charged and cathode is positively charged. And I told you this is a Daniell cell. This electrochemical cell represents a Daniell cell. Now, first let me discuss what is the use of or function of salt bridge. The salt bridge helps in the movement of ions between the two solutions without mixing of the solution. and the salt bridge also helps to maintain the electrical neutrality. So these are the two functions of salt bridge. The first function, it helps in the movement of ions from one solution to other without mixing of the solution, and the second is it helps to maintain the electrical neutrality, and it also helps to complete the inner circuit. So that is a function of salt bridge. Now let us discuss the features of Daniell cell. So I told you, you take any electrochemical cell. So if you are thorough with the example of Daniell cell, you can construct any electrochemical cell. Any electrochemical cell you take, there are two half cells. One is oxidation half cell and the second is reduction half cell. In oxidation half cell, we have anode. The electrode is anode dipped in electrolyte, and the reduction half cell we have cathode dipped in electrolyte. And the two electrodes, that is anode and cathode, are connected by a wire and an ammeter or voltmeter. And the two solutions are connected by a salt bridge. Now let us discuss about Daniell cell. In Daniell cell, you can see the electrode at which oxidation takes place is the anode. So you can see oxidation takes place in oxidation half cell, or oxidation takes place at anode, and reduction takes place at cathode or in the reduction half cell. Now here zinc acts as anode and copper acts as cathode. Now you can see the anode is negatively charged and cathode is positively charged in any electrochemical cell. Now the next is, you can see when the cell starts functioning, the electrons will flow from anode to cathode and the current will flow from cathode to anode. So the movement of electron and current is in opposite direction. Now let us see the reactions taking place at anode and cathode of a Daniell cell. Now in a Daniell cell, what happens is, first we know that at anode the oxidation takes place, and at anode the zinc from zinc electrode will go into the solution as Zn2 plus ions. That is, zinc gets oxidized to Zn2 plus ions. So this will go into the solution Zn2 plus. So when Zn gets oxidized to Zn2 plus, electrons are released and these electrons will move towards the cathode. So we can write the reaction at anode of Daniell cell as, at anode the reaction taking place is zinc, which is in solid state, that is the electrode, will get oxidized to Zn2 plus. It goes into the solution, that is zinc sulfate, by losing 2 electrons. That is because Zn to Zn2 plus from 0, the oxidation number of zinc is 0, 0 to plus 2, it should lose 2 electrons. Now electron will move towards the cathode. Now you can see at cathode the Cu2 plus ions from the solution, that is from copper sulfate solution, will gain these electrons and they get reduced to copper metal. The copper metal gets deposited on the cathode. So you can write the reaction at cathode of a Daniell cell. At cathode, the reaction is Cu2 plus plus 2 electrons. Cu2 plus is from the solution. It gains 2 electrons and you get copper solid, which gets deposited at cathode. Now if you write the overall reaction of a Daniell cell, overall reaction of a Daniell cell, the reaction is between zinc and copper sulfate. In copper sulfate, Cu2 plus, so zinc solid state, Cu2 plus aqueous will give Zn2 plus plus Cu, Zn2 plus aqueous and copper solid state. So this is the overall reaction taking place in a Daniell cell. So the reaction in Daniell cell is between zinc and copper sulfate solution. Zinc will get oxidized and Cu2 plus will get reduced. So this is, and you can see, since zinc goes into the solution as Zn2 plus, you can see that the mass or weight of zinc electrode decreases. Since Zn is getting oxidized to Zn2 plus, the weight of zinc electrode gets reduced and there will be excess of Zn2 plus ions in the solution. Now, here you can see Cu2 plus ions will get reduced and go into copper, which gets deposited at the cathode, which means that the weight of cathode increases. And you can see when Cu2 plus gets reduced, there will be excess of sulfate ion in solution. So, the cation and anion, excess of cation, the excess of cation here is Zn2 plus and excess of anion here is SO4 2 minus. They will move towards the salt bridge to maintain electrical neutrality. So, the function of salt bridge is to maintain electrical neutrality without mixing of the two solutions. And also it helps to complete the inner circuit. So this is about Daniell cell or electrochemical cell. So any electrochemical you take, there will be two half cells, oxidation half cell and reduction half cell. In oxidation half cell, oxidation takes place and we have anode dipped in its electrolyte as oxidation half cell, and reduction half cell we have cathode dipped in its electrolyte. And always anode is negatively charged and cathode is positively charged. And in any electrochemical cell, electrons will always move from anode to cathode because oxidation is taking place at anode, and the current will flow in the opposite direction, that is from cathode to anode. So this is about the Daniell cell. Now suppose I apply an external opposite potential to Daniell cell. You can see on the board, I have drawn the Daniell cell. Now, again, here I have shown an external opposing potential applied to the Daniell cell. Now, that external potential is denoted by E external, and E cell denotes the cell potential. That is the potential difference between two half cells. That is the cell potential, and or you can call that EMF of the cell, and EMF of Daniell cell is 1.1 volt. So what I did is I connected an external opposite potential. I applied an external opposite potential to the Daniell cell. Now you can see the reaction will continue as such, or this cell will continue to work as an electrochemical cell as long as E external becomes less than E cell. That is, external potential becomes less than the cell potential. The cell potential of a Daniell cell is 1.1 volt. Now, when E external becomes equal to E cell, that is, the external potential applied as well as the cell potential becomes equal, you can see there will not be any flow of electrons or no current. If there is no flow of electrons, then no current. So the reaction will stop when external potential becomes equal to cell potential. Now again I am increasing the external potential, that is E external will be greater than E cell. Now the cell will work again, but now the direction of flow of current changes. Now you know, if it is an electrochemical cell, the flow of current direction is from cathode to anode. Now when I applied an external potential greater than cell potential, the flow of current changes its direction, which means the movement of electrons also get changed. Now in this case, when external potential becomes greater than cell potential, now the electrons will flow from cathode to anode and the current will flow from anode to cathode, which means our anode and cathode are interchanged. That is, again I have to change this plus minus. Now we know that electrons will flow from anode to cathode. So our copper will act as anode now with positive charge, and zinc will act as cathode with negative charge. So now you can say this cell behaves like an electrolytic cell. Now you cannot call this an electrochemical cell, this is called an electrolytic cell. That is, when I applied an external potential greater than cell potential, now the reaction took place but in opposite direction. So now the cell behaves like an electrolytic cell. So in electrochemical cell, the chemical energy produced in a reaction, redox reaction, is converted into electrical energy. Because you can see in our Daniell cell, this is our electrochemical cell, that is Daniell cell, in which the chemical energy produced in a reaction is converted into electrical energy. That is, it results from the chemical energy produced, whereas in an electrolytic cell, you can see the electrical energy, because we applied more external potential. The electrical energy applied is used to bring about a chemical reaction which is non-spontaneous. So in electrolytic cell, when the same cell works as electrolytic cell, the anode and cathode will get reversed. Means now the copper acts as anode and zinc acts as cathode. So this is electrolytic cell. Okay. Now suppose you are asked to construct an electrochemical cell taking copper and silver nitrate. Copper and silver nitrate. You can construct an electrochemical cell. For this, you have to take again two half cells in which copper electrode is dipped in copper sulfate solution and silver electrode is dipped in silver nitrate solution. So this is silver nitrate solution and this is silver electrode, because the reaction is between copper and silver nitrate. Copper in copper sulfate solution, and the two solutions are connected by a salt bridge, and this is connected by a wire and an ammeter. Now again you can see in this is our oxidation half cell and this is our reduction half cell. And here the copper will get oxidized to Cu2 plus and 2 electrons are released. They go to cathode, and at cathode the Ag plus from silver nitrate solution will gain that electron and it gets reduced to Ag and it gets deposited on cathode. So current will flow in this direction. Now if you are asked to write the reactions at anode and cathode for the electrochemical cell between copper and silver nitrate, at anode copper will get oxidized to Cu2 plus 2 electron, and at anode Ag plus will get reduced to Ag, solid. Now you can see, since it is 2 electron, to balance the equation we have 2 Ag plus giving 2 Ag. Now the overall reaction can be written as copper plus 2 Ag plus gives Cu2 plus 2 Ag. So if you look at the overall reaction, you can see copper is getting oxidized to Cu2 plus and Ag plus is getting reduced to silver. So with this, we finish a brief description about electrochemical cell. And you know, when the external potential applied is greater than the cell potential, an electrochemical cell will act like a electrolytic cell. So electrochemical cell the chemical energy produced in a redox reaction is converted into electrical energy, but in an electrolytic cell, the electrical energy is used to bring about a chemical reaction which is non-spontaneous. Thank you.